Hello everyone, this is Sakshi and I welcome you all to my edtech platform Waited On. So we are going to solve PYQs from GATE exams because we are also going to learn the GATE exam, learn for the GATE exam, the upcoming GATE exam. So I hope you all have applied for the GATE. So let us start the first 10 sums of this PYQ marathon, and these 10 sums are from mathematical physics. So let us start the first question, which is from GATE 2001. So here it is given that a vector A is given. Okay, so I can write this Ex cap, Ey cap, Ez cap as unit vectors for my convenience. I need to find del square A. So we basically know that del square can be written as dou square by dou x square I cap. So we know that the A vector is xi plus yj plus zk. So when you differentiate twice this vector, so when you differentiate one time, your x will become a constant, which is 1. And when you differentiate again, this will become 0. Therefore, del square A will be 0. Okay, so let us see the next question, which is again from GATE 2001. And we have to find here the value of the residue of sine z by z power 6. So if you see here, sine z by z power 6. So you can just say that z is equal to 0 whole of order 6. Right. So now we are going to use the residue formula. Residue at z is equal to 0. Which will be 1 by 5 factorial. Sorry, this is 5. Differentiating 5 times this function. Okay, I'm just using the residue formula for order of n folds. Okay, so instead of n, I'm using this order 6. Okay, so you'll have to look into the formula once if you're not clear with these steps. So on differentiating sine z 5 times, so when you differentiate one time, let y be sine z. When you differentiate one time, you get cos z. Second time is minus sine z. Third time is minus cos z. Fourth time is sine z. And fifth time is cos z. Okay, so on differentiating this sine z 5 times, I get cos z. So at z is equal to 0 pole. So I get 1 by 5 factorial cos z at z is equal to 0. Okay, so at z is equal to 0 means cos z at 0 will be 1. Right. So our residue will become 1 by 5 factorial. So in the question we have been asked only the residue. So you do not have to use the Cauchy integral formula. You have to choose only 1 by 5 factorial. Okay, so let us see the third question of the day, which is again from GATE 2002, and here a unit vector normal to the surface at the point is. So you have to find the unit vector normal to the surface. So basically, to find the unit vector, let that be n cap. You will have to take del phi by the magnitude of del phi. So what is del phi over here? Phi is nothing but your surface equation. 4y minus z is equal to 0. So now you'll have to use this operator del phi, and you get del phi is again dou by dou x I cap plus dou by dou y j cap plus by dou z. Sorry, it's not I cap j cap. Yeah, correct. A cap into your phi. Okay. So now you're going to use this n And when you differentiate the x term, y term, and z term, you're going to get 6x I cap plus 4 j cap minus k cap at the point 117, 1 comma 1 comma and 7. So you're going to get, on substituting these points, you get 6i plus 4j minus k cap. So this is your del phi. Now you have to find the magnitude, which is nothing but 6 square plus 4 square plus 1 square, which is going to give you 36 plus 16 plus 1. Yes. So on doing that, you get 53. Now let us write our n cap, which is 6i plus 4j minus k cap by root 53. Okay, so which suits option C? So this is your correct answer, the unit vector normal. So let us see the next question, which is again from GATE 2002, and here you have to find the solution of the differential equation given. So this is some sort of like a tricky question here. So instead of going with the question, instead of solving the differential equation, you can use the options over here. So I know what is the option, right option over here. So I'm going to use that particular option and show you how to proceed for such kind of solutions. Okay, so now you have 1 plus x d square y by dx square plus x dy by dx minus y is equal to 0. Now it will be somewhat time taking process for you to solve. Okay, so I'm going to use the option and use the one of the option as a solution and substitute that in this differential equation. Now let me take option B, which is the actual answer. So let me consider y is equal to ax plus b e power minus x. So I'll have to find d square y by dx square and dy by dx. So dy by dx will be a minus b e power minus x. And d square y by dx square will be, a is a constant now, so it will vanish, and you're going to get b e power minus x. Okay, so now we have to substitute these values in this given question. So 1 plus x into b e power minus x plus x into a minus b e power minus x minus ax plus b e power minus x is equal to 0. So you have to check if this satisfies the condition, that is the LHS should be equal to 0. So let us solve this. We will be getting b e power minus x plus xb e power minus x plus ax minus xb e power minus x minus ax minus b e power minus x. So this one will vanish. This will also vanish, and this is also going to vanish, and you are going to get equal to 0. Hence, option B will satisfy. So this is a simple question. So let us see the fifth question, which is from GATE 2002. Again, it's from vector. So it is given that the given vector is solenoidal. So we'll have to find the constant A. So for solenoidal, we can say that del of A will be 0. Okay, so we know that del is dou by dou x I cap plus dou by j cap plus dou by dou z k cap into 5x plus 2y I cap plus 3y minus z j cap plus 2x minus az k cap. This should be equal to 0 according to the condition. So on differentiating this I term, j term and k term with respect to x, y and z, I am going to get 5. This is with respect to x. This is just with respect to y, and this is with respect to z. So with respect to y will be here plus 3, and with respect minus a, which is equal to 0. So I am going to get 8 minus a equal to 0, hence a will be 8. So option C is the right answer. So let us see the next question, which is from GATE 2003, and this is from Fourier Transform. Okay. So here the function f of x, okay, the Fourier transform of function f of x is given as this. Now we have to find the Fourier transform of df of x by dx. So this is one of the property. If you remember, you can directly answer. But if you do not remember, then we are going to do it as a complete process. So here our function has changed to df by dx. Okay. So instead of f of x, I'm going to use df by dx. So f of k will be e power ikx df by dx dot dx. Okay, so now I'm going to use Udv formula. So I'm going to consider u as e power ikx and dv as df by dx. So I'm going to get my du as ik e power ikx dx, and my v will be f of x. Okay, so I'm substituting over here uv minus vdu formula. That is integral udv is equal to uv minus integral vdu. Okay, fine. So on substituting this, I'm going to get f of x e power ikx minus infinity to plus infinity. Remember the limits of Fourier transform in the integral that we have to use. Basically, if you don't have any kind of limit, then you can use from minus infinity to plus infinity. So then next process is this. So this will go to 0. Okay, and we know that this is equal to f of k, right? F of k is equal to minus ik into f of k. Okay, here the f of k is for df by dx. Hence, option C will be right. Or you can remember this as your a property too, where the Fourier transform of df by dx will be minus ik into Fourier transform of f of x. Okay, this can be used as a property too. So let us see our next question, which is from GATE 2003. Okay, and here you're going to learn two new formulas over here. So for symmetric, we have to find the number of independent components. So number of independent components of symmetric. You can say symmetric matrix or symmetric tensor, whatever it is. Okay, so for symmetric will be half n into n plus 1. And similarly, number of independent components of antisymmetric matrix or tensor. You can use anything over here. Half n into n minus 1. So remember these two important formulas. Okay. So now, what is n over here? Sometimes okay, the question will have n directly. Sometimes you'll have dimension which says about n. So it's 3 dimension over here. So let us consider n is equal to 3. So for symmetric, it will be half 3 into 3 plus 1, which will give you 12 by 2, which is equal to 6. And for antisymmetric, it is half 3 into 3 minus 1, which is equal to 6 by 2, which is equal to 3. So 6 and 3 respectively. Okay, so remember these two important formulas. Add in the formula notebook of yours for matrices or in a common maths formula notebook. Okay, let us see the next question, which is from vectors again. So you can see vectors are being asked many times in GATE exam. Okay, so a curl of vector, we have to find the curl of a vector. So we know that del cross A will be I, J, K, dou by dou x, dou by dou y, dou by dou z, and then particular AX, AY, and AZ. Okay, this is the curl function. And now here we have A vector as Z I cap plus X J cap plus Y K cap. Now the curl function gives you I, J, K, dou by dou x, dou by dou y, dou by dou z. And for I component is here z, x, and then y. Now on taking determinant, we are going to get dou by dou y into y will give you 1, and this will be 0. 1 minus 0, then minus j cap. This will be 0, 0 minus 1 plus k cap, 1 minus 0. Hence the answer for del cross A will be I cap plus j cap plus k cap, which is option A. So this is a very easy question which was asked in GATE 2003. Now let us see the ninth question, which is from GATE 2003, and it is about differential equation. So now we know that this differential equation can be written as d square plus 2d plus 1 of x is equal to 0, and first you will write the auxiliary equation, which is m square plus 2m plus 1 equal to 0. Now the roots will be m is equal to, m is equal to minus 1, comma minus 1. Okay. Yeah. So m is equal to minus 1 and minus 1. You can see that these are real and equal roots. Okay. So now for real and equal roots, how can you write the answer? Like the solution. Solution is written as a plus bt e power minus t. Okay. So now we have the condition that at time t is equal to 0, x is equal to 1. At t is equal to 0, x is equal to 1. And x dot is equal to 0. Okay. Similarly, okay, so first let us solve this x dot over here. So on doing that, you get, I'm going to first simplify by UV method. So when I simplify e power minus t, I get a plus bt e power minus t, and then e power minus t remains the same over here into b. This is my x dot. So this is your condition now. So at t is equal to 0, x is equal to 1. So x is equal to 1, t is equal to 0, you will be having only a. So now you got that a is equal to 1. Now x dot is equal to 0 when t is equal to 0. So you will be having e power, that is minus a plus 0, e power 0 plus e power 0 into b, which will give you 0 is equal to minus a plus b. So you know that a is equal to 1. So here from this you know that b is equal to a, and therefore b will be also equal to 1. Now you can write the solution as x is equal to 1 plus t e power minus t. This is your solution. Okay, so now it is asked that at t is equal to 1, the value of x is equal to what? So at t is equal to 1, so x is equal to 2 e power minus 1. Therefore x will be equal to 2 by e. 2 by e. So which is option B. So I hope this is an easy question for you to solve. Let us see the 10th question of the day, and here you can learn a new important property for you to check if the following function will exist or not for a Fourier transform. So Uh, Fourier transform. Just remember this. So Fourier transform exists only for those functions if the function is zero or finite at x is equal to plus or minus infinity. So here I'm going to take option C and I'm going to check in the plus or minus infinity. Okay, so e power x square at x is equal to infinity will give you e power infinity square, which is e power infinity, which is infinity. So this does not satisfy. Again, you can try for minus infinity 2, which is you're going to get the same. So this does not satisfy. Because we know that e power infinity is infinity and e power minus infinity is 0. Therefore, you can say that only option C will not satisfy this condition and hence the Fourier transform of this particular function does not exist. So I hope you like this session of PYQ marathon, and if you have any kind of suggestions or if you have any kind of doubts, you can just comment me and I can clarify your doubts. So thank you. See you tomorrow with more problems and more solutions for the GATE exam and CSI NET exam. So thank you. See you tomorrow. Ta-da.